Assalamualaikum dan selamat sejahtera. We are going to proceed to chapter 6.4, chemical properties of carbonyl compound. Okay, at the end of the lesson, you should be able to study about all this, yeah? Okay, so you can read it, but we are going to study in this chapter, yeah? Okay, first what we need to do is to know the reactive site. Okay, so what is shown to you here is a carbonyl compound. In this case, it is aldehyde. This is actually aldehyde, but the same thing applies to ketone. Okay, the same thing applies to ketone in terms of reactive site. Okay, in carbonyl group, the carbon oxygen double bond is polar. So this is the carbon oxygen. Carbon double bond oxygen is polar, with oxygen bearing a partial negative. So it is shown by the label D negative there, delta negative. So oxygen, this oxygen is partial negative, and carbon, this is the carbon shown by D positive. This one, that is bearing partial positive charge. Okay, and that give you what can occur to carbonyl compound nucleophilic addition reaction. Okay, so this is nucleophile. Okay, nucleophile, because of this part is positive and this part is negative, so nucleophile that is negative can attack the positive part. So when it attack the one that is positive, carbon, so this bonding will move forward to bonding is actually lone pair, so the lone pair will move to oxygen part. Okay, so this reaction is addition of nucleophile, nucleophilic addition reaction. So you are going to add nucleophile to ketone or aldehyde. Nucleophile is rich in electron, high in electron density as shown earlier, and it can be species that exist with unshared pair of electron. It can be, for example, if you have HCN, when it breaks, when these two breaks, it will form H plus CN minus. CN minus because it have lone pair. So this is the lone pair. So the lone pair will make CN become the nucleophile. So this one become nucleophile because it have lone pair electron that can be attached to carbon. So you can see that oxygen become negative, nucleophile already attached. Okay, it is attached to the carbon, so oxygen become negative. So oxygen can now bonded with H plus. H plus is usually from acid, the dilute acid that available in the solution. So what you will get is nucleophile attached first to the carbon, and then you see OH. H is from the acid. So this is nucleophilic addition reaction. Nucleophile is added first. This is what we call electrophile, right? But because nucleophile is added first, we call this nucleophilic addition reaction. Okay, now from the nucleophilic addition reaction, what are the reactions that can occur to carbonyl compound according to nucleophilic addition reaction? So we can see here reaction with KCN plus or NaCN H plus. So what actually is being formed from these two things, NaCN and H2SO4, is what you want to form is this thing, HCN, where this thing will break into H plus as earlier I told you, it will become like this. Okay, H plus and Cn minus with one lone pair. So nucleophilic addition, this is the nucleophile, right? So this nucleophile will be attached to this carbon. Okay, carbon, and OH here will be attached with H. Okay, H here is from the acid. So let's see the answer. Oh, before that, HCN is prepared in situ. We are going to prepare HCN from this. We are going to prepare HCN. And this is the reagent that you can use, NaCN or KCN with H2SO4. But actually what you want to produce is this thing, HCN. So the product here you will get, if I draw this thing, okay, CN OH and CH3. Why is it like this? Because from HCN, Cn minus will be attached to this one. The bonding will move to this part, and H will bonded to this one. So you can see this is the product that you will see. Okay, next reaction that can occur to carbonyl compound. So you can actually reduce this carbonyl compound, this is carbonyl compound, to become alcohol. Okay, what is reduction? What is reduction? Reduction is opposite of oxidation. Okay, it is opposite of oxidation. Okay, if I write down like this, reduction, oxidation. In terms of chemical reaction, oxidation usually it means that you are going to add oxygen, right? Okay, so it is called oxidation. Or you remove H, it is also oxidation. Reduction is opposite of oxidation, which means you are actually going to remove O or add H. So that is reduction. That's the difference. It can be either one. Reduction can only remove O, can only add H, or it can do both. The same thing with oxidation. Oxidation means that it can either add oxygen or remove H only, or it can happen both at the same time. So let's see here what happened. So you can see that from here, R, O at the C. So now you can see that we have R, O, but now one more H is added. This H is added. So it means this one undergo reduction. So this one, what you get is reduction, and then the reagent that you get, that you need to use, is ether and lithium aluminum hydride. Okay, this is explanation here, lithium aluminum hydride. And then step 2, you further react this one with acid H plus for it to have reaction with H plus, and you see H plus here, this H plus actually react with this oxygen. So you get OH. So this one you add 2 hydrogen. One hydrogen at this part and another one at this part. So this one is reduction because reduction is adding H or remove oxygen, right? Oxygen is not removed here, but hydrogen is being added. Okay, so this is the explanation, step 1 and step 2. It can occur to primary and secondary alcohol. Okay, example for this one. Okay, what is the reagent that you need for the first step? Ether, and this one lithium aluminum hydride. Some student pronounce this thing, but I don't suggest for you to pronounce Lia. No, do not pronounce it. It is lithium aluminum hydride only. So what happened? What is this process? This is reduction to alcohol. Reduction to alcohol. Okay, so what you will get, this part will get added with hydrogen, right? Okay, let me draw. If you cannot understand this, maybe you can repeat the previous explanation. Okay, so this is the H that is going to be added. C, H, H. Okay, this is step 1. So further reaction with dilute acid. So you will get C, H, C, O, H, C, H. So this is the second hydrogen that is being added. So this involves step 1. This is step 1, and this is step 2. Okay, so now you get secondary alcohol. This is this is secondary alcohol produced from ketone. This is ketone. Okay, one more example maybe. This is aldehyde. The same thing. What is the reagent that you need? Ether. Okay, ether and lithium aluminum hydride. Okay, why do we use lithium aluminum hydride? Okay, as you notice, you should notice that hydrogen hydrogen here is added to carbon. Okay, hydrogen is added to this carbon. If you remember earlier, carbon is positive, partially negative, positive, partially positive. So what can be attached here is nucleophile. Nucleophile is something negative, but hydrogen here usually it is H plus, right? Okay, H plus. So lithium aluminium hydride actually produces H minus as the nucleophile. So that's why we need to use lithium aluminium hydride. You cannot use dilute acid here. Okay, so let's see what happened. So ether lithium aluminium hydride, and you can see that it forms something like this. Okay, and then C negative hydrogen and hydrogen. So this is the hydrogen that is being added in step 1, and step 2 react with dilute acid. Draw the structure again. The differences is that you only need to add you only need to add H. Okay, this is the H that you are going to add to the compound. Okay, so this is primary alcohol. This is primary alcohol. So aldehyde will produce primary alcohol. Okay, so this is reduction to alcohol, whether you are going to use ketone or aldehyde, but the class of alcohol depend on ketone or aldehyde that you use. Yeah, if you use aldehyde, primary alcohol. If you use ketone, secondary alcohol. Okay, next one. Condensation. Condensation with 2,4-dinitrophenylhydrazine, or this one also called as Brady's test. Yeah, Brady's test. Aldehyde ketone contain carbonyl group, so Brady test with Brady reagent will detect the presence of carbonyl group. Okay, and this is 2,4-dinitrophenylhydrazine. If I draw the structure, it is like this. Okay, and H. Okay, this is hydrazine part. NO2 and NO2. Okay, so that this is the 2,4-dinitrophenylhydrazine. Okay, example. What you can see that this is condensation. Condensation means that water is being displaced, disposed, something like that. So this is the H2O that is going to remove. You can see that this is the water that is being displaced, and C will be bonded with N, will be double bonded with N. So I hope you can see this. Okay, this is the carbon. This is the carbon that attached to the N. Okay, the carbon can be attached to the N because this thing is being displaced or disposed. Okay, so this is the double bond. Okay, so whether ethanol or whether you have aldehyde, ethanol is aldehyde, or ketone, the same reaction will occur at the C double bond O part. Okay, so the structure will be like this. You might think this is difficult. It is difficult. It is not actually difficult. For me, it is not easy yet for you. If you study this, it will become easy. Even for me, it is not easy yet if I didn't study this thing. But when I studied it, it will become easy. You are better than you think you are. Do you need more example? Okay, more example lah. This one actually a blank slide for me to show something for you. Okay, let's say we have a kind of aldehyde. Let's say this aldehyde. Okay. So this is actually ketone lah. Earlier is ethanol. CH3. So this is actually propanol. Propanol. Okay, propanol because it have 3 carbon. 1, 2, 3 carbon. And react with 2,4-dinitrophenylhydrazine. Okay, the structure here I remember because I didn't forget it. Okay, so remember this is condensation, Brady's test, condensation using 2,4-dinitrophenylhydrazine. This is the 2,4-dinitrophenylhydrazine, and this is the water that is going to be eliminated. So you will get, draw again the structure, CH3, C, CH3, double bond, N, H, okay, benzene ring, NO2, NO2, okay, plus H2O lah. H2O is the byproduct. And this product actually will give you yellow precipitate. So it means that the reaction is positive. When it forms the yellow precipitate, is no yellow precipitate is formed, means that it is not having any carbonyl group in the compound. Okay, next one, oxidation with Tollen's reagent. Okay, let's see oxidation of aldehyde. We are using Tollen's reagent because we want to differentiate aldehyde from ketone, because aldehyde are easily oxidized using the Tollen reagent. Ketone does not oxidize. So this is the reagent. So let's see what happened. So ethanol, when you react with 2Ag NH3, 2 is just for the stoichiometry. Even if you don't put 2, it's still okay. Okay, so what happened? This thing will become carboxylate ion. Okay, this part will become carboxylate ion. You see here. Okay, so the changes here is this part. Okay, H become O minus carboxylate ion, and 2Ag. This is the observation that you can see. Ag, silver mirror form. This is also used for chemical tests, and this is the byproduct, 2NH4 plus and 2NH3. Okay, more example. Okay, this one. So what can occur to this thing? This thing is Tollen's test. So Tollen's test using Tollen's reagent to determine the presence of to differentiate aldehyde and ketone. So when it react with argentum, Ag and H3 to OH minus, remember this one will become, okay, carboxylate ion, right? Okay, so this one is carboxylate ion, not acetate ion. Acetate ion is specific for 2 carbon atom. This one you have cyclopropane. So no, this is just carboxylate ion. Carboxylate ion for any structure that have this thing. We call that carboxylate ion. Plus 2Ag. We put 2Ag because of 2 lah. If you don't put 2, means that no need to put 2 lah. Okay, so I show the arrow down here to show that the silver mirror form attached to the wall of the vessel. Okay, and there are two more byproduct, but that byproduct is okay. This is the 2 things that is important, carboxylate ion and the silver mirror. Okay, what about ketone? Easy. Ketone are resistant, so no changes. If you have ketone, this is the ketone, the same reagent, the same condition, no changes because ketone are resistant towards oxidation. Okay, next one, iodoform test. This one is for us to determine the presence of methyl ketone group. Okay, methyl ketone group. What is methyl ketone group or methyl carbonyl group? Is it drawn? Okay, let me draw first for you. What is methyl carbonyl group? Okay, methyl carbonyl group is, okay, let's say you have O here, CH3. Okay, so this is the methyl and this is the carbonyl. The presence of this kind of structure Okay, the presence of this kind of structure, we call it methyl ketone or methyl carbonyl group. Okay, the methyl must attach directly to the carbon with the double bond with O. Okay, it must be like this. Okay, so if we refer to the example that is shown here, is there any methyl attached directly to the carbonyl? Okay, yes. So this is the part. Okay, this is the part. The methyl attached directly to the carbon with double bond O. Okay, the reagent iodine and NaOH. So this is iodine and this is the OH minus from NaOH. So what will you get is CH3I. This is the iodoform. This is the iodoform, not CH3I, CHI3 iodoform. So this one also yellow precipitate. Okay, and this one is actually still carboxylate ion. Okay, so that is iodoform test. Iodoform test is only to test for the presence of methyl carbonyl group or methyl ketone group. Okay, more example. Based from this structure, this is iodoform test. So methyl attached to carbonyl. So yes, there is the presence of methyl carbonyl group at this part. So what happened? Okay, of course, the first thing that you get is CHI3. I draw the arrow at the bottom to show that yellow precipitate form. Yellow precipitate form. And you should draw all this structure in form of carboxylate ion. So draw like this. C double bond O, O minus, okay, sorry, to draw again. Okay, I draw better, sorry. Okay, C double bond O, O minus, CH2, CH2, CH3. Okay, this is the structure. I didn't draw the CH3 here because this CH3 already forming this part. Okay, it already forming this thing. So no need to draw lah CH3. Okay, no need to draw CH3. That's why this as test, iodoform test the presence of methyl carbonyl group, because that methyl part will form the CHI3, the iodoform. Okay, so that's it for chemical reaction of carbonyl compound. So good luck, study hard, study smart, bye.